Hello children, welcome to 9th Chemistry online classes. Is matter around us pure? Is it pure? No. Mixtures are not pure. They are impure substances. And in this lesson, we already learned types of mixtures and some separation techniques to separate the mixtures. And today we are going to learn physical change and chemical change. And one more thing, that is the very important thing, that is types of pure substances. We already learned types of impure substances, that are mixtures, and today we are going to learn types of pure substances. Let us see. Physical change and chemical change. So first we see physical change. So first is physical property of a substance. What are physical properties of a substance? Properties of a substance such as rigidity, color, fluidity, boiling point, melting point, density, and hardness, which we can observe, are called as physical properties. So these all terms are we already learned in chapter 1. So these are the some physical properties. We can see or we can feel, we can see that things, okay, that rigidity or color, fluidity, boiling point, etc. So these properties are the physical property of a substance, okay. So they are, or these are the physical properties of a substance. Now we see what is a physical change. When physical properties of a substance change, it is known as physical change. It's very easy. Physical properties, okay, that is rigidity, color, fluidity, etc. They are called physical properties. So any change of that physical property, we can call it as physical change. When we convert a substance from one state to another, such as solid into liquid or vice versa, or liquid to solid, like, it is also a physical change, as only the physical nature of the substance changes without affecting its chemical nature. So when we boil water, so water is the liquid state. When we boil, it changes from liquid to vapor stage or gaseous form, okay, but still it is what? H2O. Its chemical nature is H2O. It's not change, okay. Physically only they have a change, but chemically nothing will happen. So that kind of change is called physical change. Example, change of ice into water. The chemical properties of water remain the same, okay. Ice also H2O, water also H2O, and water vapor, that is also H2O. Chemically no, nothing, but only the physical change. So that is the physical change. Chemical property of a substance. The chemical nature of a substance is known as its chemical property, such as its chemical composition. Chemical nature of a substance. So what is chemical property? Chemical nature of a substance is known as chemical property. Example is chemical composition, H2O. So its composition is 2 parts of hydrogen and 1 part of oxygen, okay. They chemically combined, not physically combined. They chemically joined or combined with each other. That is the chemical composition. So any the chemical nature of substance is known as chemical property. Then what is chemical change? When the chemical properties or chemical composition of a substance get altered or it changed, it is called chemical change, okay. So chemical properties having any change, we can call it as chemical change. Physically any change, we can call it as physical change. It's quite simple. It is also called as a chemical reaction. So that is also very important. Chemical change, we can call it as chemical reaction. Chemical change is a chemical reaction. Example of chemical change is burning of paper. Okay, so when you burn a paper, we get what? Ash. So from the ash, can we make the paper again? No. So that ash is a complete new product. Paper is one product, and when we burn, a reaction occurred and we get one completely different ash. So that is called chemical change. So another example also I will tell. Cutting of vegetable. Cutting of vegetable is which kind of change? Is it a physical change or chemical change? That is a physical change, because cutting vegetable means its shape changed, but still that is a vegetable. But you just think cooking of vegetable. So that time not a physical change, that is the chemical change. So because from the cooking or cooked vegetable, we cannot get back that raw vegetable. Okay, so that is the chemical change. Another example, burning of candle. Burning of candle, both changes takes place here, both physical change as well as chemical change. What is the physical change? Melting of wax, because the candle is made up of wax. So melting of wax is the physical change, because after melting, when it is solidified, we'll get back the wax. So that is a physical change. But the center part of the candle, that is the wick, that wick when we burn, it changed to ash, or that burned after get ash. So that is a chemical change. Okay, so in this burning of candle, both physical and chemical change takes place. Types of pure substances. The beginning of this chapter, we already discussed that substances or matter is classified as pure substances as well as impure substances. Impure substances means mixtures, and they are homogeneous mixtures and heterogeneous mixtures that we already learned. And pure substances are classified as elements and compounds. So we see what are elements. An element is the simplest form of matter. And one scientist, its name is Robert Boyle. He was the first scientist to use the term element. Okay, he brought this word or this term element. And Anthony Laurent Lavoisier, one scientist, a French chemist, he gave the definition of an element. And what is the definition of an element? An element is the simplest form of matter. Elements cannot be broken down into simpler substances by chemical reactions. So element is the simplest form of matter, and we cannot broken down into simpler substances by chemical reactions. Elements are further characterized as metals, non-metals, and metalloids. So elements we can see. So the number of elements known at present are more than 100, or we can clearly say that it is 118 elements at present. And among that elements, some are metals, some are non-metals, and some are metalloids. So this is the periodic table, and about the periodic table we will study in 10th standard. So now we just see periodic table means the elements are arranged in one table for the sake of study. Okay, so here that blue color elements are the metals, and yellow color that are non-metals, and you can see some zigzag green color elements that are the metalloids. Now we see what are metals, non-metals, and metalloids in detail. Metals: silver, mercury, copper, gold, sodium, magnesium, iron, zinc, etc. They are the examples of metals. And now we'll see the properties, general properties of metals. General properties that I think you already studied in 8th standard. Metals are lustrous, that means shining appearance. Metals conduct heat and electricity. They are good conductors. Generally, metals are good conductors of heat and electricity. Metals have a silver gray or gold yellow color. They have silver gray or gold yellow color. We can hammer metals and form thin sheets, and that property is called malleability. Can make thin sheets, so that called malleability. And we can convert metals into wires, so drawn into wires. That property is called ductility. Metals always produce a ringing sound if they are hit or drop down, so that property is called sonorous. And metals are hard. So these all properties are the general properties of metals, and some exceptions are there. Okay. Then non-metals. Examples of non-metals are carbon, iodine, chlorine, oxygen, hydrogen, nitrogen, etc. Then what are the general properties of non-metals? Non-metals do not conduct heat and electricity. So generally non-metals are poor conductors, or we can call it as insulators. Non-metals are not sonorous. Okay, they are not making the ringing sound, and generally they are not hard, and they are not lustrous or ductile or malleable. Okay, and next general property of non-metal, they have varied color. They have various colors are there, but metals they have particular colors, but non-metals they have different colors. So they are the general properties of non-metals. And what are metalloids? Example, silicon, germanium, then boron, that also, then antimony. They all are the examples of metalloids. You can see in that periodic table. Okay, in the 5th slide, I have given that periodic table. You go and see what are metals and what are the non-metals and metalloids. And metalloids means they show some properties of metals and some of the non-metals. They showing the properties of metals as well as non-metals. That is why their name is metalloids. Now we see some quick facts of these elements. These are very important. There are 118 elements known to us. 92 elements out of them occur naturally. Okay, so 92 are naturally occurring elements, and the rest are man-made. Most of the elements are solid in nature. Example, carbon, iron, silver, gold, aluminium. These all are solid in nature. At room temperature, 11 elements exist in the gaseous state. Example, hydrogen, oxygen, nitrogen. Okay, so these are elements are in gaseous form at room temperature. At room temperature, 2 elements exist in the liquid state. They are bromine and mercury. So we already learned that metals are hard. Okay, but some exceptions are there. I already said some exceptions are there. So 2 elements like bromine and mercury, they are metals, but they are in the liquid state. Bromine and mercury, bromine water, we can call it as bromine water. Bromine is a metal, but it exists in liquid state, bromine and mercury. And the last point is At a temperature slightly higher than room temperature, two elements exist in the liquid state, that is cesium and gallium. So they are in a solid state, but the temperature is more than room temperature. Or we will take the solid cesium and gallium in our palm or in our hand, that temperature high, and it start to melt. Okay, so that two elements, they are in solid state, but temperature is slightly above the room temperature, it changes state to liquid state, or it start to melt. They are cesium and gallium. Next, pure substances are compounds. And what is a compound? It is a substance that consists of two or more substances. These substances are combined chemically with each other in fixed proportions. Okay, so chemically combined substances, two or more substances, and they have some fixed proportion also. That kind of substances are called compounds. The properties of a compound are different than that of its constituents. Okay, I will explain that. First, we will just see some examples of compounds. Carbon dioxide, CO2, carbon, one portion of carbon and two portions of oxygen. Hydrogen sulphide, H2S, two portions of hydrogen and one portion of sulfur, H2S. And water, H2O, two portions of hydrogen and one portion of oxygen. And ammonia, NH3, one portion of nitrogen and three portions of hydrogen, NH3 ammonia. Okay, so these substances, example carbon dioxide, CO2. So two substances are there, carbon and oxygen, and they are combined chemically, chemically combined, and they have a fixed proportion, carbon 1 carbon and oxygen 2. This fixed proportion, and that is called compounds. And one more line here, the properties of a compound are different than that of its constituents. That means when we are taking the example of water. Water is the combination of hydrogen and oxygen, or the formula of water is H2O. Two hydrogen atoms join with, chemically combined with one atom of oxygen. Okay, that is H2O. So we know that hydrogen having some properties and oxygen also have some properties. Okay, and when they are combined, chemically combined with each other to form a compound, that compound, that is the water has some other property than this hydrogen and oxygen. Got it? Hydrogen has one property, oxygen also has other property, and when they mixed or chemically joined together to form a compound, that substance has another property. Okay, now we see the differences of mixtures and compounds. So first, you know that mixture is an impure substance and compound means pure substance. Okay, now we'll just see what are the differences. First point of mixture, elements or compounds just mix together to form a mixture and no new compound is formed. Example, sulfur and iron filings. They mixed together in any proportion. We can take any proportion and we just mix together, and a new compound is not formed. The same thing, but a mixture. Okay, and what about a compound? Elements react to form new compounds. Example, in the same sulfur and iron filings, when we heat together, they react to form a new product. Okay, and that new product is completely different from iron and sulfur, and the product name is iron sulphide. Okay, And we just see the second point of mixture. A mixture has a variable composition. So I already told that we can take any amount of iron filings and sulfur. Okay, so that is variable composition. But compound, the composition of each new substance is always fixed. Example, water, 2 hydrogen, 1 oxygen. Ammonia, 1 nitrogen and 3 hydrogen. Okay, so there is some fixed proportion, but in the case of mixture that is variable, not fixed. And third point, a mixture shows the properties of the constituent substance. Taking the same example, the sulfur and iron filings mixture. So when we are taking that mixture, it shows this sulfur shows its property and iron shows that property. We can see the color of sulfur there in that mixture, and we can see the iron also there. Okay, so it shows separate its own property. But in the case of compound, the new substance has totally different properties, and this hydrogen and sulfur chemically react with each other to form the compound iron sulphide. That property is completely different from the property of sulfur and the property of iron. The last point, the constituents can be separated fairly easy by physical methods. Example, this same iron filings and sulfur mixture. So using a magnet, we can easily separate iron filings. Okay, but in the case of iron sulphide is a compound, so it is not easy to separate iron and sulfur. So that last point of compound, the constituents can be separated only by chemical or electrochemical reactions. Okay, that one example I'll tell. Water is constituents are hydrogen and oxygen, or hydrogen chemically combined with oxygen. So by passing electricity, that you will study in next chapter or 10th standard, I'm not remembering. Okay, anyway, this when passing electricity through water, the water separate as hydrogen and oxygen. Okay, actually water is a compound, so by passing electricity we can separate it hydrogen and oxygen. So that is the end of this chapter. Okay children, so all of you watch this video, not only this video, all these video, I put all the videos in the your Google Classroom also. So all of you watch that all videos from first to 3 times. Okay, and read the textbook also, then only you will get the content. Okay children, so all the best. Thank you.